There is a question concerned with the topic of Kinematics or M1. The question is, a car of mass 1200 kg is driving along the state horizontal road at a constant speed of 50 meters per second. There is a constant resistance to the motion of 350 Newton. Part 1. Find the power of the car engine. The car comes to the hill inclined at 1 degree to the horizontal, still traveling at 50 meters per second. Part 2. The car starts to descend the hill with the reduced power and with an acceleration of 0.12 meters per second square. Given that there is no change in the resistance to the motion of that car, find the new power of the car engine at the instant when it starts to descend it to the hill. Third part, when the car is traveling at 20 meters per second down the hill, the power is cut off and the car gradually slows down, assuming that the resistance to the motion of that car is 350 Newton. Find the resistance, the distance traveled by the from the moment when the power is cut off until the speed of the car is reduced to 80 meters per second. Since this is a car on a horizontal road, that is R, the normal reaction, this is the weight, this is the driving force, and this is the resisting force. Since it is moving at a constant speed of 15 meters per second, so that means acceleration is equal to 0. So first of all, we use this equation, driving force minus resistive force is equal to ma, and that thing is equal to 0. Driving force we don't know, but the resistive force is 350 is equal to 0, or driving force is equal to 350 Newton. Since we are going to find out the power, so power is basically equal to driving force into velocity. So driving force is 350 and velocity is there, that is 15. So that thing is equal to watts, or even you can write it as 5.250 kilowatts by dividing it by 1000. Now in the next part, the car is moving on horizontal surface and then it is inclined at plane this with 1 degree to the horizontal. So at this point, we know that R mg cos theta, this is mg sin theta, and there is also the driving force for that object. Still, the resistance force they have given equal to 350 Newton. And with an acceleration of 0.12 meter per second square. So first of all, we will solve this equation, that is driving force and mg sine of 1. This is the total driving forces minus the resistive force is there, that is 350, Mass of that particle is 1200 into acceleration of that particle is 0.12. So driving force will be equal to 350 minus mg sine of 1 plus 12 into 12, 144 Newton. This will be equal to 350 minus m is 1200, g is 10, sine of 1 degree plus 144, and this is the driving force for that particle there. And now we will calculate it. 284.6 Newton, and new power is driving force into velocity. So that is 284.6 into 15, and that value is equal to 4268.6. Watt, or you can convert it to the kilowatts. The next part, the third part of this, since engine is off, so there is no driving force. So that thing is equal to 0. So this force will become equal to 0. Now, the component which is responsible for its downward motion is mg sine of 1 minus 350. Mass is 1200 into acceleration a there. So that value of a we can calculate it as acceleration is 0.117 meter per second square. Now we are going to calculate the total distance traveled. 2s is equal to v square minus u square. 2 we know, acceleration is 0.117. S we are going to calculate. V is 18 square minus u is 20 square. So S value will be equivalent to this value is 324.78 meter is the total distance traveled when it is coming downward on that inclined plane.